Good afternoon. I'm Karen Yetter, Director of Marketing, and on behalf of Mercator Advisory Group, I'd like to thank you all for attending our webinar, FinTech, Bank's Biggest Weapon. There will be a Q&A session at the end of today's webinar. If you have a question during the presentation, you may submit it online by clicking on the questions panel. If we do not get to your question, please email info@dataseers.ai. I now present to you Tim Sloan, Vice President of Payments Innovation at Mercator Advisory Group.
Thank you, Karen, and hello, everybody. I'm here with Adwait Joshi, the CEO and head seer of DataSeers, a company that has been a joy to work with in the way they've implemented machine learning AI solutions within the financial industry and FinTech. Today we're going to take a look at how that machine learning solution and machine learning in general can be applied to financial institutions, to transactional-based systems, and take a look at how that's been done within the DataSeers implementation, and generalize that a bit as to how it can operate across a distributed ledger and in other environments. And so in order to do that, Adwait, why don't you take the next slide and kind of walk us through the DataSeers platform and specifically focus on where you're using machine learning within this environment to be able to speed up the way you find data and integrate it, and then be able to analyze it and produce insightful reports.
Absolutely. Thank you for the introduction, Tim. Hey, everybody, this is Adwait Joshi. And as Tim suggested, I'm the Chief Seer at DataSeers. So we have taken a different approach than most people. We have taken a AI-first approach or a machine learning-first approach when it comes to banking and payments. The assumption was that as we progress throughout the data world, AI becomes more and more relevant. But is everybody really ready to do machine learning on their data? Is the data ready to be fed into these algorithms? Because we all know garbage in and garbage out. So we took a little bit of a different approach and we said, what if we did garbage in and quality out? So how do we do that? We actually take the data regardless of its source, meaning it can be your 8583 message, it could be your settlement files, it could be files coming from your processor, any format, any volume, any velocity. We feed it in through our file and message seers. The job of these seers is to actually clean the data, ingest the data, label the data, and augment the data. Before any machine learning algorithm takes over, we have to make sure that the data is clean, labeled, and fully complete, or at least as complete as possible. Otherwise, the algorithms will actually fail and produce a lot of noise. We understand and we accept that the payments data is not always clean. There is a lot of things in there that are not usable as is. It requires that we have to go through iterations. So we have built logic and data cleansing routines where no matter how clean or ugly the data is, we can actually make it super clean on the other side. And we use AI in many different ways. So AI is really at the heart of our appliance. First of all, we reconcile those transactions. Only when we reconcile the transactions, we know that we have full data. We actually have financially accurate information. On the reconciliation side, the AI is used to predict a particular settlement position. So the idea is, can we actually say how much money will settle tomorrow? So it's a predictive analytics on settlement patterns and load patterns across programs and platforms and people. On the compliance side, of course, we do AI to figure out transaction patterns that indicate money laundering, transaction patterns that could indicate some sort of trafficking, stolen identity patterns, whether a merchant is a storefront for money laundering, and so on and so forth. On the fraud side, we use AI to predict and detect early fraud. So this is more of, is someone trying to scam the system and trying to commit a fraud in near time future? A classic example would be tax fraud. When people actually want to commit tax fraud these days, they don't just start committing fraud in first or second week of February. They actually wait on the platform for a good 6 to 9 months and make the platform believe that everything is okay and that you're not a bad guy, and then suddenly commit fraud. So the idea is, can we look at those patterns beforehand and tell you what is happening? So we do this out of line, not in line, more on the back end. And on the DataSeers side, it is a classic example of pure predictive analytics around people, around transactions, around merchants, around networks, and trying to figure out what's happening here. So we can go from your raw, unclean, unusable data to meaningful insights for all these 4 verticals in a matter of minutes.
Adwait, what amazed me was in talking to the bank that has implemented your platform was the benefit of your platform having been designed, recognizing the different reports and analysis that needs to be done relative to a banking system and a card system, and how that guides how you go after the data and how you massage that data into your own repository within the distributed file system. It was clear that by having a very specific goal, your file message seer is capable of finding data much faster, of reconciling and filtering that data and cleaning that data in a way that your system understands is required for all of the other AI machine learning tools you're going to apply to it. He identified that this was initially across multiple silos. It only took 3 or 4 days to get all that data in and ready to be analyzed, which is pretty remarkable.
Yep, agreed. Yeah, and that's the key. It's the speed, it's the volume, velocity, and the variety. The ability that we can handle it at that speed.
So why don't you give us, Adwait, a overview of some of the benefits that you've been able to deliver using this approach?
Absolutely. So when we went to one of our banks, they were really struggling seeing this data coming in. They had an issue where their employees would be logging into multiple different systems. And of course, issuing banks work with multiple different providers. So every provider, every processor has their own data sets, their own data labels. An ATM transaction could be called many different ways across the board. And so they had tremendously hard time trying to consolidate all of this information and be able to react in a timely manner. And we all know that FDIC is not a big fan of that. They want to make sure that everybody has a good oversight when it happens to their data coming in, whether it is compliance, fraud, you're able to reconcile your accounts and so on and so forth. So when we implemented this solution at one of our clients, during that time, their business actually increased 100%. They were able to reduce the time to onboard new customers by 75%. So they could actually onboard a new processor, a new program, and not have to worry about how are we going to do the compliance oversight. They can keep accelerating on the front end and say, okay, bring on all the programs that you can, because I have a backend system that can handle these unique needs and these unique requirements pretty easily. They also were able to increase the oversight for employee oversight, which means before their employees would be able to look over a certain number of accounts, and that's how they measured operational efficiency, that one person can, let's say, was able to look at 1 million customers. They saw a 10 times increase in the number of accounts to be managed by a single employee. And this happened because we were able to reduce the noise, and we were actually able to give them the data in one place. They didn't have to go and log into multiple different systems. It was a single source of information. So we truly created a data lake. And what happened before was it took them about 45 business days to make sense of all of this data coming in. And you're talking several 100 million transactions coming in onto the platform, and now they're in the billions. It took them a while for the data warehouses to process, to get this data in, to fix the errors in the data, to be able to spit out the reports, and so on and so forth. And it would take them typically about 30 to 45 days to actually get this information in place, and it's too late. When we put this system in place, literally within a matter of minutes, in about 5 minutes or so, this information can be ingested because the appliance operates as a multi-node cluster. So think about thousands of minions working and crunching this data at the same time. So you have power of distributed computing, you have power of big data and AI that is crunching at this data and able to come up with results much, much, much faster. So these were some of the published results that our clients saw.
And in talking to the client, it was impressive. They also identified that not only was there a reduction in time to onboard those new customers, but obviously that's no good unless it meets all the regulatory requirements for checking and validating the customer, and having the confidence that those customers are indeed meeting all those regulatory approvals was a major part of their confidence in this platform. And that goes to the ability to manage an account with reduced manpower, being able to increase the number of accounts by tenfold with the service reps, while being sure that everybody is being serviced in a way that meets regulatory requirements is critical. I guess that kind of brings us to the next slide, which is the other aspect of this is being able to integrate in a significant number of partners and data streams into the environment across multiple partners, across multiple systems, to be able to keep it all running and to be able to do the appropriate regulatory and management of the platform and the solution. So maybe you could talk a little bit about this slide, Adwait.
Absolutely. And this is a problem that we deal with every day, and we call it the data demon. The data demon is nothing but, we can handle big data, right? The world has shown us that big data can be handled. But when they really started big data, the word came off because of the size of the data, because of the volume of the data. And clearly so, today we are at a point of, quintillion bytes of data being created every day. And that's, a large amount, and we have technology that can handle that volume. But what's also happening is it's coming to us in different formats, and it's actually coming fast, right? So IoT gave us the different shapes of data, which means now I have XML, now I have JSON, all different formats, and so on and so forth. And then it's also creating fast because you have thousands of devices out there that are generating this information. So if you think about what this has done for payments, right? The innovators like Square Cash and Venmo and DoorDash and Instacart, they're pushing so many transactions, Uber going and pushing transactions through their systems. Over in Asia, you have people like Paytm and Ant Financial that are enabling all of these payments. And with that volume and velocity and variety becomes a real problem that we call the data demon. And a data demon is nothing but an inability to ingest and analyze this data. And you can see that companies have spent millions and millions of dollars, in some cases hundreds of millions of dollars, to try and control this. And some have succeeded, many have failed. And this goes back to why are we able to do this differently than every one of them, is because of some of the technology that we use underneath, right? We wanted to solve a problem. We did not want to reinvent the wheel. So what we did was we actually used the same technology that LexisNexis uses, which is a high-performance computing cluster, HPCC. And HPCC systems was developed before Hadoop. And if you look at their use case, it was specifically developed to handle data coming in from multiple different random sources, whether it is structured, whether it is unstructured. In their cases, they collect code documents, they collect driver records, they collect housing records, and so on and so forth. So there had to be a system that could handle that. And the system was already developed. It was kept a secret for a long time, and then it became open source. And we used that. So we said, why reinvent the wheel? Why can't we use something that's already out there? And we used that in a very efficient way. And that's kind of the key as why we have been able to handle the volume, velocity, variety. We were earlier talking about a use case that we are being put to test at a scale of 30 million transactions a day. And that's 900 million transactions a month. And we are trying to run our fraud algorithms on them and try to figure out how quickly we can catch it. The scale doesn't scare us at all. It's something that is imbibed into our systems. And that's truly how the industry is today. And that's what, in a way, the cloud does, except we run this on more of a private cloud rather than a public cloud. And we use the technology that was meant to handle the volume, velocity, and the variety at the same time.
So in talking to one of Mercator's clients, they were discussing the challenges they had with their platform, in that they were selling their prepaid product on their website using a third party. They were selling their product through malls through a distributor. They had internal over-the-counter sales within their own shops. They had money out going over multiple card networks, over the ATM networks, and cash over at stores. And they had money in through a reload network. And so you've got multiple banks, multiple settlement windows, multiple different methods of sending the data in to the platform supplier, which made reconciliation a nightmare. Being able to use a solution that's based on machine learning and can predict what those volumes should be, even if they're not necessarily settling all in the same window, certainly gives a lot more confidence that you have control of your business and can represent what is accurate. So to me, that was a great learning moment as to why you would want to apply machine learning and prediction to the management of the platform. Obviously, with all of those different windows and all of those different money movement areas, it suggests that there's a challenge in fraud. So Adwait, perhaps you could discuss how the platform manages looking for the fraud.
Absolutely. You actually hinted on something earlier, so I want to kind of quickly, on the tail end of it, add something before we go here. You mentioned reconciliation, and reconciliation is a big nightmare, right? It's different timings, it's things that settle immediately, things that settle the next day, things that don't settle for a while. It's all permutation combination of things that happen, which make it absolutely hard to truly reconcile the platform and move forward with it, right? And it's a real challenge. Now, one of the things that we have done, and we have taken a different approach, is at the end of the day, it's a math problem. At the end of the day, the debits and the credits have to add up. They may not add up in the timeline that we want it to add up because of the rules being different. So what we have done is we actually have created a unique way of being able to reconcile transactions that have settled. The things that have not settled, we actually can use AI to predict when they would settle, because we have transaction patterns. For example, I mean, you know this, when you check in at a hotel, you are putting your card on hold. There is no knowing on the back end when that settlement would come in. You might be staying there for 2 days, you might be staying there for 7 days, and so on and so forth. But there are rules and within AI that we can actually predict the settlement. So even if we see something is not reconciling, we can actually say, oh, don't worry about it. It's going to reconcile on blah, blah, blah day based on the patterns that I have seen on your platform. And that is what makes it very unique, because not everything is going to add up on the same day. Eventually it should, and it will, but it may not add up in a timeline that you're used to. So that's how we have used AI to actually predict the settlement patterns and identify what is settling and when. And of course, the classic example of fraud detection, of AI is fraud detection. And we do that, right? One of the very important things, again, I have said this before, but I like to emphasize to people is if you want to use AI and machine learning, you have to have good quality data. If you don't have good quality data, no matter if you got the best scientist involved, is not going to be able to solve your problems. The reason is because think about it as in a simple way. You're trying to teach a computer how to identify a dog and how to identify a cat. The only way the computer is going to identify a dog and identify a cat is if you actually show it enough pictures of a dog and a cat. Show them enough pictures from different angles, different lighting conditions, different colored dogs and different colored cats, and so on and so forth. And even then, if you showed it a picture of a bear, it's not going to know that it was a bear because it's only trained to identify a dog or a cat. And that's key, because when you run your training algorithms, you have to have your data modeled in certain way that your algorithms can pick up on it. So what we do is, our step one is we collect data from all possible sources. In a funny way I say this, I'm a data guy, which means naturally I'm a hoarder. I hold on to everything that you give me. And that is a key in how we do this. We actually don't delete anything from our system. We actually keep everything, because many times at the time of making a decision, we don't know what else we might need. So we would collect the data. In a typical example, right, in a payments world, we want the data that's coming over the networks. We want the data that's coming from the core bank. We want your ACH files. We want things that are happening on the processing side. We want data from your IVR systems. We want data from your website. We want data from your mobile applications. And that's a lot of data. I mean, if you told a data science guy or a data analyst and said, I'm going to give you all of this data, the first thing that would go through his mind is, okay, how am I going to store it? How am I going to clean it, and so on and so forth. So for us, that is second nature, right? We literally ingest all of that data. It comes in, we clean it. When I say we clean it, a lot of times we get merchant names where a merchant name might include a location number. Walmart might be spelled Wal space Mart, Wal dash Mart, Walmart one word. It might say WM Supercenter, and so on and so forth. It might have hashtag location IDs in there. So that becomes a big deal for us to clean and identify that no matter what you mean with WM or Walmart, it's actually the Walmart that I know it is. So we clean it not only on a merchant name level, but we also go through and try to identify what else needs to be cleaned. Has the data shifted? Instead of giving me address line 1, have you given me just numbers in address 1, and then the rest of the address is actually in address 2? Is the city-state zip combination match? Have you given me a fake city-state zip, which means, are you saying Atlanta, Georgia 28412, which is a North Carolina zip code? So are those things happening in the platform? So we actually look at all those little things. There is over 100 different things that the system looks at when it cleans the data. Then we label it. And this is the most important step, because without labeled data, no algorithm in the world is going to do its job. The labeling process is important because what we want to identify is what was actually fraud. What does the transaction tell me that has already happened? So historically, can I identify the bad actors? Can I identify the good actors? And of course, I'm going to have a mix of bad actors and good actors. But if I have a clean set of bad actors and a clean set of good actors, I can actually separate the mixed set of good actors and bad actors. So the labeling is also very key. We actually do this ahead of time based on what the data is telling us. Then we augment that data. How do we augment it? A lot of times there is information missing. There is logic in our algorithms that figures out that, okay, this is a merchant that I don't know a lot about, and for whatever reason, my score on that merchant has come down tremendously. So it's in the low 20s. And I need to be able to know more about this merchant before I can say that this is truly fraud. So we have the ability to go out and grab additional data points that you may not have provided to us and bring that to the table. A classic example would be a merchant showing you that this is my registered MCC code, whereas they're actually doing transactions on a whole different MCC codes. There are services out there that we partner with where we could actually identify that this merchant is transaction laundering. There is a storefront, but they're actually laundering money, and so on and so forth. So that's a key in what we do. So when we tell people we know more about your data than you do, it is because of the data augmentation piece. We have partners on the back end like LexisNexis, which can provide us additional data points that we may or may not have. They call it a thin file, which means I have gotten very little information about an individual or a business and so on and so forth. We also subscribe to third-party databases. So we have OFAC files, PEP sanctions lists coming onto our platform. We have high-intensity drug trafficking, high-intensity financial crimes. We have the death master lists and so on and so forth. So we have various data sources that we have access to that are integrated onto our platform that we can tap into and augment the data. Once the data is augmented, we use a combination of algorithms, right? And the reason why we use a combination of algorithms is because there is a lot of different things that can happen. To give you a simple example, it could be a classic time series problem. It could be a classic clustering problem where certain individuals are acting in a typical behavior that is exhibited by another individual. So clustering tells us that these 2 people in California are behaving exactly same like these 10 people in North Carolina, and there is a very strong relationship between them and their transactions. The data augmentation piece, we can actually make a call to databases like LexisNexis and say, hey, is person A related to person B? Or do you have any information with a connection between person A and person B? And a lot of times there is information available, there is links available. So what has happened in this case is you have gone from a local crime at one state to a crime at a much higher level, and suddenly it became a federal case, right? So we use a combination of AI. We use, to start with, we use supervised learning because there are cases where we may not have enough information and there might be internal expertise within the banking or the FI that we are working with. So we use their knowledge, we ask them to train our data sets as we go, and then it eventually gets towards automated sets where I have learned everything that there is and I will now continue to act on it. And of course, there are cases where we still end up having to make a decision, and that will get kicked out in a queue to an individual and say, I'm sorry, but I can't make a decision on this transaction. Can you tell me whether you think it is right or wrong? And with that approach, we have seen that there can be a very high fraud detection rate. One of the biggest keys and one of the biggest successes that we have seen is in noise reduction. A lot of times, systems identify fraud. They will give you a transaction that it identifies and says, here is a fraud transaction. But along with it is going to give you 500 other transactions that it thinks fraud and that are not really fraud. I was talking to somebody specifically today about it, and they said that we have so many transactions that are coming to us. The ratio, specifically, they said, for every 5,000 fraudulent transactions that I can guarantee, there is 30 million transactions that come out, and the math doesn't add up for me, which means I know there is fraud, but there is no possible way I can look through all of these transactions. And this is happening because the fraudsters are coming up with newer techniques and new use cases and trying to exploit the system where rule-based systems just plain don't work. So we are in a unique position because of our approach to identify these anomalies, identify these patterns, and increase the detection rates and reduce the noise just by running your data through our system.
Adwait, we've received 2 questions. The first one is about the GDPR right to be forgotten. So as you're collecting all this data, how do we manage to either eliminate PII information or enable that data to be deleted when an individual asks for it to be deleted? I think I know the answer, but I'll let you take it.
Absolutely. And this is a very interesting question. I got this question from a lot of people. And, I'll give you a high-level answer and then I'll get into more detail. At a high-level information, there is still enough bit of confusion out there around this scenario, because I'll tell you why. This is financial transactions. This is regulatory data, which means if you did something and I have a suspicion that this was fraud, and you come to me and tell me that, okay, go ahead and delete all my information, I'm legally bound to keep it and report to the authorities off of it. I cannot simply delete it. There is pieces of information I can delete, absolutely. I don't need to know everything. There is some things that I can get rid of, but there is a ambiguity out there around what information can you actually delete and what information you are supposed to keep, because the compliance rules and the compliance laws allow you to do that. And it also goes into the T's and C's of the end customer. In that, what does the clause say? What do the disclosures say? Do the disclosures say that we are supposed to keep this data for regulatory purposes? So from a reconciliation perspective, I can anonymize all of it. I can encrypt it one way, which means it's gone. It's there on our platform, but it's no longer identifiable, and reconciliation will still work and everything will still work. But if it's a fraud or compliance issue, it becomes a little bit more sensitive, and there is enough ambiguity out there as to how can you handle that piece of information.
Thank you, Adwait. The other question is about the marketing approach of machine learning AI, and how much of it is really machine learning and how much of it is just basic analytics. I did a report about 2 years ago that went into depth into the way that AI and machine learning has been brought into the market through the analytics teams. In essence, I think you start off by asking, are you using supervised or unsupervised learning? And if they don't know what that means, you walk away. And I've had that happen many times. If they indicate that it's unsupervised, well, it means they're doing traditional analytics against the data. If they're doing supervised, you can then ask a range of questions about how that supervision is taking place, the depth of the machine learning model, whether it's deep learning. You can also ask about how many models they use. In fact, that fits into another question we just had, which I'll pass over to you in a minute, Adwait, about how do you manage false positives. Almost never do you have just one model. And in this instance, I would say you probably have a model that is designed to find fraud, and you also have a model that's being used to define and look for false positives. And then it's a balance between those models. There are companies that have machine learning platforms that do nothing but look for false positives to reduce the impact of false positives on a large card base. But I'll swing it over to you now, Adwait, to talk a little bit more about how your platform looks for false positives.
Absolutely. So there were two questions. One is this just analytics, or this is truly machine learning and AI? So let me address that first, and then I will come to false positive. They're kind of hand in hand. So we actually are truly using algorithms, right? So there is the difference between analytics and machine learning and AI. I mean, there is no solid line, just like there is no line between compliance and fraud. The line is very fuzzy. There is definitely a line between machine learning and AI. According to me, AI is more when things are completely automated. The machine is making the decisions for you, whereas machine learning is you're actually training the machine to act how you want it to act. A classic example would be you're training a car to drive between the lanes. Now it's looking at data, it's learning, and it's staying between the lanes and it's driving. That's more of a machine learning. AI is being able to react. I'm about to have an accident, so I need to brake, and it made that decision on its own and it braked. So that is more of an AI piece. So in our case, we actually truly use algorithms on here to detect what is happening. Anomaly detection is almost impossible just by doing analytics. To me, analytics is very basic, right? There's four pieces of analytics. Yes, we have, reactive, we have prescriptive, predictive, analytics, and you can do predictive analytics. And once you start getting into predictive analytics, you actually start using techniques in machine learning. You start using techniques like decision trees. You start using techniques like time series analysis. You start using binomials, multinomials. You start using Bayesian algorithms to kind of figure out the predictive analytics, and so on and so forth. You use different techniques of regression. So some of the analytics that we have had before, I'll use a different word. I will use statistics. The statisticians that we used to call statistics, those models still apply, right? Regression is regression. Regression is going to be used everywhere. What data science has taught us is that, it's like you have multiple different tools, and how do you use them in harmony with each other? Because let's just be honest, there are problems in the payment space which cannot be solved alone by clustering, and they cannot be solved alone by a time series analysis. So we actually use a combination of time series and clustering. So it's a clustering on top of a time series in order to identify, do these patterns happen during a particular time of the of life, during a life cycle of a car or a consumer. So very different. So we truly use a AI platform. We actually learn from everything that is in there. So it's definitely more science involved than pure analytics.
Yeah.
Now, how do we stop the false positives? And that's a very good question. And it is a continuous improvement, right? I will never be able to walk into a bank or a FI and say, I'll take all of your data and there will not be any false positives. There will be zero false positives. And why does this happen, right? It's because fraud's not static. These behaviors are not static. The behaviors are ever evolving. And false positive is nothing but the mistake that a computer makes because it cannot stay between those lines. It will say, I'm about 80% confident that this is a problem, but it's saying that it's 20% not sure. And that's where it comes and becomes a false positive. So we handle false positive with the supervised approach, right? If it is a false positive, if our algorithm predicted something that was not true, when you say that in our alerting and case management system, in our transaction monitoring system, if you go and say this was a false positive, that goes right back into our decisioning. So I'll give you a simple example. Let's say our algorithm identified weights, and let's say the SSN had a weight of 65%, and it triggered a false positive. It's possible that because of that false positive, the fact that you marked it as a false positive, the weight may get adjusted to something lower. It might go to 64 or 63, and then it will see, okay, how about now? And then it will run the algorithm. If it still continues to be an issue, to keep on adjusting those weights as it continues. I wish there would be a world where there will not be any false positives. The fact that there is false positives, which means we are learning. So if you look at Einstein's quote, is that if you haven't made a mistake, you haven't tried something new. So false positives we actually take them in a very positive way, not a negative way, because the fact that there is false positives could potentially mean that there is a newer pattern that my algorithm has not learned yet. And we use the human feedback for that, because that is inevitable, that somebody is watching this and they're telling us what's happening, and we use that as a feedback and improve our algorithm.
Thank you, Adwait. And I think we have about 10 minutes left, and I'd like to get on to how machine learning and AI can be used with a distributed ledger. We talked about how important clean data is to the machine learning tool. And the distributed ledger is all about being able to collect transactions in a reliable and safe way and have them distributed and available to all the participants within the distributed ledger. So perhaps you could talk a little bit about the types of distributed ledger, where you've seen it used in an environment where it could be applied to the financial industry.
Absolutely. So we have a very unique use case, and we have a very unique product when it comes to DL. And the whole concept goes back to augmenting the data. The whole concept goes back to saying that, okay, what if I don't have all the information that I need in order to make an informed decision? How am I going to augment my data? In this case, we are actually using a distributed ledger on top of our AI device to share this information across multiple different FIs and banks. So the idea was that, yes, there is enough competition in this world, but we know that the largest banks in the world came up and created Zelle in order to reduce fraud. They combined their workforces and they said, we are going to create a network where we will be able to do things differently and have less fraud. Similarly, in this case, what you're actually doing is you're sharing this information because the logic is that a fraudster is not going to stop at committing fraud in one environment. So if you walked into a Kroger and you had a different acquirer and a different credit card and a different the back end, and you went into a Publix and you used a different credit card and a different acquirer and a different issuing bank on the back end, except you exhibited the same behavior, won't you want to know that immediately and instantaneously? Distributed ledger can replicate the data. Now it is with great power comes responsibility. So you can look at the main fact that you can't just replicate all the data. You cannot replicate billions and billions of transactions. It would create a big mess. So what we do is our AI algorithm predicts these transactions, flags these transactions, puts them out into the distributed ledger based on when it thinks it is necessary that this information be available to rest of the banks. Once that is there, it then replicates instantaneously, and the people who don't have this information and that information just became available then gets ingested in. Talking about false positives, think about external parties reducing your false positives by providing valuable results. That's how it all plays in.
Thanks. And so perhaps thinking that through, it means that individual banks can perceive and collect data that is relevant to, say, a fraud event or to some other activity that needs to be communicated effectively and will improve if it's just communicated immediately rather than, say, in a SAR report sometime a week later, if you're going to help other banks avoid similar fraudulent activity. So what happens when you connect your platform up to that solution? I assume it's no different than connecting it up to LexisNexis or to early warning solutions where financial institutions go up to a central authority with information, and that central authority makes that data available to other institutions that are participating. But maybe you could give us a little thought about how your platform is able to leverage that data.
Absolutely. And this is key because what is happening in the international market, I mean, we cannot do this in the US. We spoke about it a little bit earlier, but in Asian markets, there are authorities that have started mandating some of this, right? So if you look at the Money Authority of Singapore, or if you look at the National Payments Corporation of India, they are mandating that the data be shared back. They're mandating that we want this information so that we can make the environment safer. So how does our solution solve that problem is we literally, in that case, wherever there is a fraud that occurs or a compliance issue that occurs that needs to be shared, we literally put it out on the distributed ledger. We supplement it with existing information. So we say, okay, this is what happened. Here is what I know about the individual, and we put it on a private blockchain. Then you distribute it across the ledger. It gets pulled back. Everybody runs their own deep learning algorithm to use this information and say, okay, I got person A. I have something else to add to this based on this, and they put it back out. Or based on that pattern, if they found person B and C, they're going to put it back out on the distributed ledger saying, hey, I used your information, and here's what else I found. And now you can actually increase the ability to find problems. There is a process that exists today in the US where banks are doing something similar, but it's a very archaic process, and it's a very old way of doing, and we call it as 314B, where one bank asks for information from another bank, and it's very slow, it takes time, and not all systems can handle it. Just think about doing this on a distributed ledger, and the 314B problem can be solved in a heartbeat.
Yeah. So it is an interesting use case, and as Mercator has looked at distributed ledgers, some of the attributes of it being distributed, being able to operate in an untrusted environment are all positive attributes. But they do have relatively rigid data structures, and they need to be in an environment where requirements change relatively slowly. And that ledger needs to be managed pretty much centrally if that isn't true. If there's going to be changes that need to be replicated across all the users, then there needs to be an authority that can make that happen. We've already seen that the voting rights model of changing a distributed ledger is not very efficient and can cause major problems. We had another question.
Correct.
We had another question, Adwait, asking about if we could address the fact that AI has been accused of being possible of being discriminatory. Certainly that is true in a credit environment. I have trouble seeing that being true in a card fraud basis, but certainly it could be in an onboarding process as well if it's not being used based on factual data. But maybe you could talk a little bit about that.
Absolutely. Absolutely. And I'll give you two examples, right? One of the examples is when you go to the airport, your faces are being scanned. Now, if your faces were scanned in a whitelisting environment, people would be very mad, saying that that's the invasion of my privacy. If you saw another person taking your picture, you would be very upset and you would say, why are you taking my picture? That's invasion of my privacy. Yet when we are at airport, our faces are scanned all the time and we are identified who we are, right? So it's in a similar way. Are we being discriminated in that case? Well, it's a very thin line to preventing fraud. There is going to be some collateral damage, right? If you think about it like you have a thorn in your foot or your arm, or you have a splinter. While trying to remove that splinter, you're going to expose skin around it, and you're going to end up, damaging some components of around that part. That's the reality of the matter. I mean, would you rather, be safe, or would you rather fail? So we would much rather err on the side of caution. So Tim mentioned it extremely well. Is that problem comes more on the onboarding side and on the credit approval side, not so much on the fraud detection side. And we see this happening all the time. I mean, I get messages from American Express on my phone where they say, we blocked this transaction because we thought you were doing something wrong. If not, please click here. And I don't get upset. They're trying to protect me. So yes, if they have a small issue where something happened, I can try again and I can move forward. Onboarding certainly can get very frictional, and customers can get very upset. And that's why there are practices where you have to disclose the reasons why you declined somebody and send them that letter in mail and so on and so forth. But it doesn't apply so much so in our world when we are doing fraud-based or compliance-based monitoring using AI.
Right. And if it were being used for a credit type situation, it would be done in a fashion where there's a person in the loop. It can collect the data, it can analyze the data, and provide a percentage likelihood. But it's up to the individual who looks at the data that's been collected to make a thumbs up, thumbs down approach on whether the credit should be provided and the reasons why. Adwait, why don't you tell us a little bit about the DataSeers itself and the programs that you operate and the platform's capabilities?
Yeah, absolutely. So we have been around for about 2 years now. We are growing rapidly here in the city of Atlanta. We just opened up our Mumbai office, made a big splash about entering the Asian market. Some of the numbers, this is actually a very one of our very first clients. I hold them very close to my heart because they actually took a risk in our company and decided to use our technology when I had no proof that this would work. And over 1 year of being in production with them, we oversee over 200 different programs, and each program has its own set of rules. We have 100 million unique card holders on there. There's actually more than 500 million card accounts because some people have more than one account. We have 1.5 billion transactions, and these are over the last 1 year only. This is a client that was a tiny bank, and they're growing tremendously in the prepaid issuing space. And our entire reaction time around these numbers is matter of minutes. So what we do in minutes and seconds, other people can do in days and hours. So we can literally use our 5 Seers to oversee that entire platform, provide value from a compliance, reconciliation, fraud, and analytics perspective. And that's what makes us truly unique. There are a lot of people who do compliance, there are a lot of people who do fraud, few people who do reconciliation and offer truly pinpointed analytical solutions. There is nobody who has taken the bold step of handling it all in a single solution, fully automated, handling the volume, velocity, and the variety of data and providing actionable insight in this quick manner.
So I had the pleasure of writing a white paper that included a mini case study on the platform. I would urge the audience, if you're interested in seeing the white paper, it describes the components that sit on the LexisNexis HPCC platform and how DataSeers has applied their AI tools and capabilities to it. Just send us a note to info@dataseers.io and request a copy and AI, and we can get you a copy of that white paper. Karen?
So that's the end of our webinar for today. Thank you for participating in today's webinar. If you have any questions or would like additional information, as Tim just mentioned, email info@dataseers.ai. Thank you, and this now ends our webinar.
Thank you, Adwait.